Hi to all. How are you everyone? Today's topic, continuation of current electricity. Now, in the last class, series and parallel combination of cells we discussed. Now, I am going to explain the mixed group of cells. Cells may be connected in the series, cells may be connected in the parallel, and cells, how they will connected in mixed group. Mixed group means some cells are connected in series and some cells are connected in parallel. Then there is a mixed group is there. Look at here one example how to find out the effective EMF and how to find out the current through the load resistance in the mixed group of cells that I am going to explain. Listen very carefully, and heading is mixed group of cells are the mixed group of combination of cells and maximum power transfer theorem. In this mixed group, when we will get the maximum power, what is the condition to get the maximum power transfer? And look at here what we are taking it here. In this n identical cells, each of EMF E and internal resistance small r are connected in one row. Look at here, this is 1, 2, 3 and so on. This is the nth cell. There are n cells, n are identical, all are having the same EMF E, and all are having the same internal resistance R. N cells, 1, 2, 3 and so on n. N cells are connected, n cells, each of EMF E and internal resistance R are connected in one row in series. Okay, this is one row, this is one row, my hand is row. Right? This is one row. In one row there are n cells. N are identical. And now such m rows are connected in the parallel. Look at here, this is the first row, second row, third row and so on. This is mth row. M. 1, 2, 3, 4 and so on. This is m. This is mth row. Okay? Mth row. Like this, m rows are connected in the parallel, and this is the mixed group. Some cells are in series, all the cells which are in one row are in the series, but the cells which are in one row, they are in parallel with the cells which are in the another row. This is the mixed group of cells. In this, total how many cells are there? Okay, there are n cells in one row. How many rows are there? 1, 2, 3 and so on. Total m rows are there. Then how many cells are there and what is the effective EMF in this case? I am going to tell. Look at here. In the one row there are n cells are there. The effective EMF is Ne. We know effective EMF in series combination. If in series combination just we have to add E plus E plus E plus E. But in one row there are n cells. Only 2 are there means E plus E 2E. 3 are there means E plus E plus E 3E. Here n cells are there, that's why Ne. Total EMF in one row is Ne, and in this row also Ne, in this row also Ne, in this row also Ne, in this row also Ne. Then how many Ne's are connected? Ne. In one row we are getting the effective EMF Ne. Then how many rows are connected like that? Like that m rows are connected. How many rows? M rows, right? What is the effective EMF in parallel combination if we connect like this? In parallel combination, if identical cells are connected in the parallel, okay, in the series combination, if n identical cells, okay, n identical cells, each of EMF E, if they are in series, effective EMF formula is effective EMF formula or equivalent EMF formula is Ne, and effective internal resistance formula is Nr. Okay, we have to add E plus E plus E in series if n identical cells are in series. In parallel combination, if n identical cells are in parallel, then equivalent EMF or effective EMF is only equal to EMF of one cell. Okay, internal resistance is equal to effective internal resistance is R by N. This already we discussed. If you have the doubt, you can revise the previous lecture, that is 3.9. In this, if they are in parallel, you will get the effective EMF equal to EMF of only one cell. That means here NE in one row, NE, 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 NE. How many cells? Okay, in the parallel combination, the effective EMF equal to EMF of only one cell. That means here EMF effective here NE, EMF, NE, 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 NE are parallel, but effective is also NE. In one row, how much EMF is there? If many rows are in parallel, then also EMF is equal to EMF in one row only. Okay, right. And now, first, I want to know how many cells are connected in this figure. Total number of cells I want to know. If you want to know the total number of cells, you have to multiply the number of cells in one row and the number of rows we have to multiply. For example, like this, there are 3 cells are there in the one row. Okay, like that, if 2 rows are there, right, only 2 rows are there, then total how many cells are there, right? In this, how many cells are there? If you want to know, these are 3 plus 3, 6. But like this, we can, in one row 3 cells are there, number of, right, cells in one row, and total number of rows is 2 rows. There are 2 rows are there, and in one row 3 cells are there, right? And if you multiply the 3 into 2, we will get the total number of cells. In order to get the total number of cells, you have to multiply the number of cells in one row and the number of rows, right? Then for that, total number of cells, first I want to know total number of cells. How you will get the total number of cells? It was very simple to find out the total number of cells. We can consider as capital N. It is the number of cells in one row into number of rows. In one row there are n cells. How many rows are there? 1, 2 and so on. This is m. That means n into m. Right? Okay. In one row n cells are there. There are m rows are there. Okay? And this is the total number of cells. And effective EMF I want to find out. Effective EMF. How to find out the effective EMF? Effective EMF is equal to, in one row, how much effective EMF is there? That first we can find out. E plus E plus E plus and so on E. There are n cells, NE. That is, NE is the one row. Like that, if many NE. In parallel, how many cells you will connect? How many identical cells you are connecting? That is not at all matter. In parallel combination, effective EMF, for example, this is NE and this is NE. Okay, like this, there are how many rows are there? There are m rows are there. 1, 2, 3. Okay, 1, 2, 3, and so on. This is m. Like this. In this case, if parallel is there, then effective EMF equal to EMF of only one cell, one row, right? That is NE. That means effective EMF is equal to NE. That means the effective EMF will not affected by the number of rows. Whatever it may be the value of number of rows, whatever it may be the value of m, the effective EMF is equal to only NE. What is the effective internal resistance, right? Effective internal resistance. Then for that, you have to know what is the effective internal resistance in one row, right? There are several cells are there. Each cell has the resistance R. There are n cells are there. Okay, we have to add in the series combination R plus R plus R plus R and so on R. That means in series combination, right, in one row we are getting the NR resistance. Okay, each cell also acts as the one resistor. Right, NR and NR and NR. Like this, how many rows are there? Right, in one row we are getting the NR resistance, right? In one row we are getting NR resistance. This each cell also has resistance, that is the internal resistance. Resistance offered by the electrolyte of cell is called as internal resistance. R plus R plus R, like that n cells are there, then the total resistance in the one row is NR, like that m rows are there, right? NR. You know already, if n identical resistors, each of resistance capital R are connected in the parallel, then their effective resistance is R by N in parallel combination. In series combination NR, but in the parallel combination R by N. Right? That means in parallel combination, if you want to get the effective resistance, okay, in one row we are getting the effective resistance NR, there are M rows are there, then the effective resistance we will get is in one row NR, that is divided by number of rows, then we will get the effective resistance. Because in parallel combination we know effective resistance formula. What is that? R by number of rows. But the number of rows is what here? M, right? But R is the NR. Okay, right. Next, I want to know the current. This total set is connected to external resistance capital R. Then the current through capital R, external resistance. I want the current through external resistance. How to find out the current through external resistance? Capital R, right? Then for that, current is equal formula. There is effective EMF by effective resistance. This is the formula. Effective EMF by effective resistance. This is the formula. Okay. Then what is the effective EMF? We write effective EMF as E effective by effective resistance is, okay, this total cells we can consider as one cell. Its equivalent is EMF is E equivalent. Its equivalent internal resistance is R equivalent. Okay, this we can also write as equivalent or effective, whatever it may be, no problem. Okay, I will write equivalent also, there is no problem. Okay, equivalent we can write, or otherwise we can write effective, there is no problem. Okay, right. And now E equivalent, okay, E equivalent by capital R plus small r equivalent. Total resistance I want, external resistance plus internal resistance, capital R plus R equivalent. Total EMF E equivalent. Equivalent लिख सकते हैं. We can write E equivalent or otherwise E effective, right? Then what is the formula for the E equivalent? E equivalent is already we know NE by capital R is capital R. R equivalent is NR by M, right? This is the current formula. Now if we will simplify this, okay, effective EMF is NE, effective resistance is external capital R, internal R equivalent. Okay, R equivalent is NR by M. And now I want maximum current, right? When the maximum current passes through load resistance, when we will extract the maximum current from this. If you want to extract the maximum current, okay, then what is the condition to extract the maximum current? That current, maximum current formula I am going to derive. Okay, now take the screenshot and note it, right? Now tell me, if you will do the LCM for this, what you will get the next equation? In the denominator NR by M is there, right? Here E equivalent we are writing NE and R equivalent we are writing as NR by M. Then next if you will simplify, how you will get equation, right? Okay, it was very simple, that if we do the simplification, that we will get I is equal to NE by, this is LCM, MR plus NR, okay, by M. This will goes to numerator, then we will get MNE by MR plus NR we will get. Okay, this is the one more formula for the current. In order to get the maximum current, then what is the condition? Okay, in order to get the current maximum, right, we have to current is inversely proportional to this term. This term should be minimum. That means MR plus NR should be minimum. Okay, I am going to modify this MR plus NR like this. I am writing, okay, this to get the current as maximum. This term should be minimum. MR plus NR should be minimum. This term I am writing like this: root MR square plus root NR square, right? Can I write like this? Root MR square is MR, root NR square is NR, plus I will write 2 into root MR into root NR minus, first I will write the minus, next plus 2 root MR into root NR is equal to minimum we should get. Okay, minimum we have to get. What I did it here, these two will become 0, minus plus will cancel. Okay, these two will cancel, and root MR square gives MR, root NR square gives NR. That means if we simplify this, we will get the above term. Okay, then here we write a square plus b square minus 2ab formula. This one, this we write as a minus b whole square. That means this we write as root MR minus root NR, root MR minus root NR whole square plus 2 root MR into root NR is equal to minimum. We should get the minimum. Okay, what I did it here, this I wrote like a minus b whole square, and now I want to get this term should be minimum. When we will get this term minimum, right? If this term is 0, okay, so if it is 0, then 0 plus something we are adding, we will get some less value. In order to get the less value, if one term we will get 0, then you will get the sum as less. In order to get the sum as minimum, then the condition is that root MR is equal to root MR minus root NR is equal to 0, right? This term should be 0, then the sum will be 0. Okay, then when sum is 0, then this term will become minimum, and this term is minimum means this current will be maximum. Then we will get as root MR is equal to root NR, squaring on both sides, then MR is equal to, we will get as NR. From this we write as capital R is equal to NR by M, right? That means this is the condition to get the maximum current. Okay, this is the condition to get the maximum current. When that means, okay, if external resistance, capital R is the external resistance, is equal to the, okay, is equal to the, what is NR by M? NR by M is the effective internal resistance. In one row internal resistance is NR, like that M rows are there, that's why effective internal resistance is NR by M. If external resistance is equal to the effective internal resistance, then current and power through the will become maximum. Okay, this condition is called as, maximum power transfer theorem and maximum current theorem. Here maximum current is flowing means maximum power will be there, right? Maximum power transfer theorem, when the power transfer will be maximum, when the current will be maximum, then the power transfer will be maximum. When power will be maximum, if current maximum, then the power also maximum. That when current will be maximum, to get the current as maximum, this term should be minimum. This term, when you are getting the minimum, when capital R equal to NR by M. If effective internal resistance equal to effective external resistance equal to effective internal resistance, then the current become maximum. Then what is the formula for the maximum current? Okay, note it, I am going to rub it. What is the formula for the maximum current? I am going to write the formula for the maximum current and maximum power. Then after that I will close today's topic. Okay, it was very small topic, and now let us see. I want the maximum current, right? Maximum current. Maximum current. Then when you will get the maximum current? If capital R is equal to NR by M, right? If capital R is equal to NR by M, then the current become maximum, that we can consider as I max. Then I will write, we have the formula already previously. Current formula is effective EMF by effective resistance. Capital R is the external resistance, internal resistance effective is NR by M. Then we will get this formula as, in this if you substitute NR by M as capital R, then NR by M as capital R, then current become maximum. Then we write I max formula as, maximum current formula as NE by capital R plus this NR by M also we write as capital R. Then we will get the maximum current formula as NE by 2R. This is the formula for maximum current. And this we can also write like this. The maximum current formula we can also write in terms of small r. Capital R we write as NR by M, right? If you write that one, we will get this n will cancel, then we will get ME by 2R, right? This we are writing from capital R is equal to NR by M. This is the formula for the maximum current. And the next one is maximum power. I want maximum power. Yes, maximum power across resistance capital R. Okay, then the power formula is power maximum is equal to I max square into capital R. The power formula in the 10th class, you know, power is equal to voltage into current or I square R or V square by R. There are several formulas are there for the power. Power is equal to voltage into current, V into I. V equal to IR, we write IR into I square R we will get. I equal to V by R, we write from Ohm's law, V square by R you will get. I am using P equal to I square R. In that if we write II is maximum, then the power you will get maximum. Then I max is formula, I will use this one. Either you will use this or this. And then we will get NE by 2R whole square into capital R we will get. Then the maximum power consumed formula is, yes, what you will get the maximum power? That is N square E square by 2 into this R, 2 square we will get. 2 square is 4 by capital R square into R we will get. This is capital R we will get. This is the formula for the maximum power transferred to the resistance. Okay, right. With this our topic mixed combination of cells, okay, mixed group of cells is completed. In mixed group of cells, if n identical cells are connected in the one row and such m rows are connected in the parallel, then effective EMF formula is NE and effective internal resistance is NR by M. Current is effective EMF by effective resistance NE by capital R plus NR by M. And maximum current formula we derived it here. Maximum power formula we derived, and we also derived the condition for the maximum current, when you will get the maximum current, right? Now if you want to get the maximum current, that this denominator should be minimum, and by that we got a condition that if external resistance equal to effective internal resistance, this is the total internal resistance, this is total external resistance. Okay, then power and current become maximum, right? Thank you for watching my lectures. Till now, if you not subscribe, then subscribe my channel. And tomorrow I am going to explain the most important topic, and that topic is Kirchhoff laws and Wheatstone bridge. And these Kirchhoff laws are very important, and every time there is a chance to get the question in the cbse exam. Actually, the coming soon topics, and there are Kirchhoff laws are there, Wheatstone bridge, meter bridge, potentiometer. These topics are very important for the long answer. You will get either 5 marks question or 3 marks question in the final exam. Okay, either 5 or 3. These are very important topics that we are going to discuss in the next classes, right? And don't miss and watch all the lectures. If you have any doubt, you can consult me in my WhatsApp number, already you know. Okay, and now thank you for watching my lectures. Thank you.